Okay, today we are in notes number 18, and we're going to learn something called synthetic division, and we're going to learn a theorem that's called the Remainder Theorem that's really important to the grand scheme of things for our main focus of this unit. So remember last time we learned about long division, so today we're going to see how that translates into something called synthetic division, which is a shortcut. But first I have a question. Is 22 a factor of 3,702? You probably don't know off the top of your head, but what you would do to figure it out is you would divide, and if it goes in evenly, then you would say 22 is a factor, and if it doesn't go in evenly, then you would say it's not a factor. And going in evenly means what? Going in evenly means there's no remainder. So what if I wasn't using a calculator and I just did long division? 22 goes into 37 once. Subtract, bring down the next one. Let's see, 150, how many times does 22 go in there? I think it's 6. That gives us 132, and we subtract. And then, how many times does 22 go into 182? I think it's 8. And that gives us 176, and we subtract. We get 6, and there's nothing more to bring down, so the remainder is 6. So what's the answer to the question? The answer is no, 22 is not a factor because the remainder was not 0. So we need to apply that idea to polynomials as well. So here's my question. Is x minus 1 a factor of this cubic polynomial expression? Well, what I'm going to do is long division, and if the remainder is 0, then yes, it's a factor, and if the remainder is not 0, then no, it's not a factor. And then from there, I'm going to show you synthetic division. And that will be our shortcut that we'll use from this point. So we're dividing by x minus 1. We're dividing into 2x cubed plus 3x squared minus 3x minus 2. So x goes into 2x cubed. How many times? X times what is 2x cubed? That would be 2x squared. Then we multiply 2x squared by x, and we multiply it by -1, and we subtract. And that gives us 5x squared. And then we bring down the next one. X times what is 5x squared? That would be x times 5x is 5x squared. We multiply that by x and by -1. And we subtract. And we get 2x. And then we bring down the next one. X times what is 2x? That would be 2. So we write that up there. Then we multiply it by the divisor. And we subtract. And we get 0. The remainder is 0. So yes, x minus 1 is a factor. Not only that, but when you divide and you get your quotient, that's your answer. If the remainder is 0, that quotient is also a factor. So what we know at this point is that this cubic polynomial factors into x minus 1 times 2x squared plus 5x plus 2. And if we could factor the quadratic part, maybe we can, I haven't tried, then we would be able to factor it all the way down to linear factors. Okay, now here comes the really exciting part of today's lesson. It's called synthetic division, and it gives you a shortcut for long division. It's shorter in space as well as shorter in time. So what we do, if we're dividing by x minus 1, we put a 1 in the box. If you're dividing by x minus k, k goes in the box. If you're dividing by x plus k, then the opposite of k goes in the box. So I'm going to put the 1 in the box, and then the coefficients of the dividend, the number we're dividing into, go in a row. So we have 2x cubed, 3x squared, -3x, and -2. So that's how we set it up. Now we're going to leave a space, and we're going to drop the first number. That is like finding the first number in our quotient. Then we multiply 2 by the number in the box, and that gives us 2 when we write it in the next space. We add the column and we get 5. 5 is the next number in the quotient, if you look back at the long division. Okay, now we multiply that by the number in the box, that gives us 5. We write it down and add, and we get 2. So 2 is the next number in the quotient. Now we multiply that by the number in the box, we get 2. We write it down and add, and we get 0. And 0 was the remainder. So this can go pretty quickly. You don't always have to do it in your head. If the numbers get bigger, you can use a calculator, but if the numbers are small, you can probably do it in your head pretty easily. So then we translate this answer. So if the last number is the remainder, the number before that is always going to be a constant. The number before that is the x term coefficient, and the number before that is the y term, or excuse me, the x squared term coefficient. If the question is just, is it a factor, and we get a remainder of 0, then we say yes. But if the question is, what do you get once you divide this, then you're going to have to put these numbers back into a polynomial and say that it's 2x squared plus 5x plus 2. So for most of today's lesson, we're going to practice this process called synthetic division. Okay, so here's another division problem. We have a quartic polynomial being divided by x minus 4. By the way, synthetic division works when you're dividing by a linear factor, so x, not x squared or x cubed, and it has to be 1x, not 2x or 3x. And in the book, they're going to write the problem like this. So they just use a fraction bar for division. So if you're dividing by x minus 4, you put 4 in the box, and then the coefficients of the dividend go in a row. So we have 1, x to the 4th, negative 7x cubed, negative 4x squared, 16x, and 84. Leave a space. Drop the first number, 1. Multiply by the number in the box, we get 4, write it down, and add the column, negative 3. Multiply that by the number in the box, we get negative 12, write it down, and add the column, we get negative 16. Multiply that by the number in the box, we get negative 64, write it down, and add the column, we get negative 48. Now I'm going to grab my calculator because I don't want to make a mistake. Okay, multiply negative 48 by the number in the box, we get negative 192. Write it down and add. Add the column and we get negative 108. Okay, so negative 108 is our remainder. Negative 48 is our constant. Negative 16 is the coefficient on the x term. Negative 3 is the coefficient on the x squared term. And 1 is the coefficient on the x cubed term. You just go up one level each time. So that means we're going to write our answer like this. 1x cubed minus 3x squared minus 16x minus 48 plus a remainder of negative 108 over x minus 4. We were dividing by x minus 4. So isn't that fun? It goes really fast. Let's try another one. We're dividing by x plus 2. If you're dividing by x plus 2, that's the same thing as x minus negative 2. So negative 2 goes in the box. Then we have 1x to the 4th. Now watch this. We have 0x cubed. You have to hold the place of each term, so 0 is a placeholder. Then we have negative 13x squared, then we have 0x, and then we have 37. It's likely that you'll accidentally leave out a 0 sometimes, and it's not going to work out then. Bring down the first number, multiply it by the number in the box, we get negative 2, write it down, and add, and that's negative 2. Multiply it by the number in the box, we get 4, write it down and add, we get negative 9. Multiply by the number in the box, 18, add 18. Multiply by the number in the box, negative 36, add 1. So the remainder is 1. So this is going to be the x, oh, sorry, I forgot my constant, didn't I? This is going to be the constant, the x squared, and the x cubed. So we have 1x cubed minus 2x squared minus 9x plus 18 plus 1 over x plus 2. Okay, let's try a couple more. I would suggest that you pause the video, try it yourself, and then see how you did. If we're dividing by x plus 1, that's the same as x minus negative 1, so negative 1 goes in the box. And then we have 1x cubed, negative 6x squared, 8x, and then we also need a 0 to hold the place of the constant. So we go all the way down to the constant. Drop the 1, multiply by the number in the box, write it down and add, we get negative 7. Multiply that by the number in the box, we get 7, add, we get 15. Multiply that by the number in the box, we get negative 15, add, we have negative 15. So remainder, constant, x term, x squared term. Do you notice that the highest term in your answer is going to be 1 lower than what you were dividing into? It's x squared and you were dividing into x cubed. So we have 1x squared minus 7x plus 15 plus a remainder of negative 15 over x plus 1. Or you could just write minus 15 over x plus 1. Okay, if we're dividing by x minus 10, we're going to put a 10 in the box. We have 1x to the fourth, negative 1x cubed, negative 100x squared, 100x, and 0 to hold the place of the constant. Bring down the 1, multiply by the number in the box, write it down and add, we get 9. Multiply by the number in the box, write it down and add, we get negative 10. Multiply by the number in the box, write it down and add, we get 0. Multiply by the number in the box, write it down and add, we get 0. The remainder is 0. That tells us we have a factor, remember from the beginning of the lesson. The constant is 0. The x term has coefficient negative 10. The x squared term has coefficient 9, and the x cubed term has coefficient 1. So we have 1x cubed plus 9x squared minus 10x, and then that's it. Okay. So the second part of our lesson is to learn something called the remainder theorem, and what we're doing now, you don't need to write, we're just looking at some patterns. So these are some problems that we actually did today. Looking at the first row, we took this polynomial and divided it by x minus 1. The remainder was 0. Now the next thing is I'm going to find f of 1, so I'm going to plug 1 into here, and I get 0. I want you to notice the remainder was 0. The function value f of 1 is 0. Okay, here's another polynomial expression. We took this one, we divided it by x minus 4, and we got a remainder of negative 108. Now if I find f of 4, by plugging 4 into this function, I get negative 108. The function value is the same as the remainder. Also notice that if I was doing synthetic division, 4 is what I would put in the box, and it's f of 4. 1 is what I would put in the box, and it's f of 1. And what we're going to see as we look at these others is the same thing is happening. If you divide by x plus 2 and you get a 1 for your remainder, then remember that's x minus negative 2. So negative 2 goes in the box. F of negative 2 is also 1. The function value is the remainder. I think we did this one as well. And this one. We did all of these synthetic division problems. We got these remainders. Their function values are the same. So if you plug in that x value, the same x value that you would have put in the box for synthetic division, the y coordinate, which is the function value, is the same as the remainder. So this is known as the remainder theorem. If the polynomial f of x is divided by the linear factor x minus k, then the remainder is equal to f of k. So you should write that in your notes. And my sort of casual wording of that is that the remainder is equal to the y coordinate of the point. This theorem is helpful because we're going to be spending a lot of time looking for roots of polynomials so that we can graph them. And if you're looking for roots, you're looking for a remainder of 0. So while we're doing that, whether or not we find a remainder of 0, we're going to be finding the y coordinates of points because the remainders are the y coordinates of points, and we'll be able to graph those points. Okay, so let's wrap it up with this. Here's a function. We're going to find the function value f of negative 5. That means the y coordinate of the point. The way you used to do it was just called direct substitution. You can still do it this way. There's nothing wrong with it. Direct substitution is where you just plug in the number. F of negative 5 would be negative 5 to the 4th power minus negative 5 to the 3rd power minus 3 times negative 5 squared plus 5 times negative 5 minus 2. And hopefully you're going to grab your calculator for that. I get 648 for that. I hope I did that right. It says do it 2 ways. So the other way is to use synthetic division and see what we get for the remainder. because the remainder is the y-coordinate of the point. So for -5, we put -5 in the box, 1, -1, -3, 5, and -2. Bring down the 1, multiply by the number in the box, write it down and add, we get -6. Multiply that by the number in the box, we get 30, write it down and add, we get 27. I'm going to grab my calculator because I don't want to make a mistake here. Multiply that by the number in the box, we get -135. Write it down and add, we have -130. And then multiply that by the number in the box, and we get 650. Write it down and add, and we have 648. So that would be the y-coordinate of the point. So f of -5 is equal to 648 either way. Okay, here's our assignment. So you're going to be doing a lot of synthetic division. I hope you have fun with that. If you're struggling with getting your synthetic division to work, I have made another video, a tutorial video on how to do synthetic division, and it uses problems 5, 11, 13, and 15 from the homework. So it will be located with the tutorial videos on Canvas, you know, how I write the assignment down, and then I have links to the tutorial videos. It'll be right there. There's also a video for 35 and 45. Thanks, everybody.